Hi, my name is Buck Woody from Microsoft. Welcome to this session on machine learning on the Azure Data Platform. PaaS isn't just the summit. Remember to explore everything it has to offer, from training and networking, local user groups, one-day local training events, marathons, virtual groups, and much more. Find more information at paas.org. Now, as we get started here, I want to point out this is an architectural session. So we're going to be diving into some tech. I will show you some examples in code, things like that. But I do want you to know that we'll be focusing a great deal on the architecture. One of the resources that I see people use far too infrequently is the Azure Data Architecture Guide. You can see I have that there in quotes for you to type in your favorite search engine named Bing. I'll let you get that text there. You can screenshot if you need to. Okay, let's pop over and I'll just type that in my favorite search engine named Bing. And then I'm just going to come here to this. It's in docs.microsoft.com. It's the Azure Architecture Guide. Back millions of years ago, I used to use these resources quite often to guide what I did inside IT. I was an IT director and I've also been IT line worker and everything else, but I used to use the Patterns and Practices group quite a bit. Well, I work with them now here at Microsoft, so let me shrink myself and move myself out of the way here so that you can see this a little better. There we go. I think we're in good shape now. You can see and read. There we go. Perfect. All right. A little housekeeping there, a little video housekeeping. All right. When you search on that, what I've drilled down to, there's the whole architecture center. There's icons and there's Visio diagrams, all kinds of things you can find that are incredibly well done. If you've not used this resource before, start with the Microsoft Azure well-architected framework. Check that out and take a look. And there are various design patterns, and then there are Azure categories. The one I'm going to come to here is on AI and machine learning. So I'll just expand that. And if you click on it, you'll notice there's a great rundown of how artificial intelligence leads to machine learning, leads to deep learning. And I gave a session on that here at the summit, which you can go learn more about. And it explains all kinds of things about how this works. But one of the things I wanted to give you was the various technologies, and we're going to highlight a few of these. This brings up an important point about this session. I will be covering several platforms that you can use inside Azure, tools and platforms for machine learning and artificial intelligence and so on, but it's not exhaustive. There are things not involving the Azure data services that are a part of this. Now, all AI runs on data, so I'm going to focus us on just that area, but know that there are more. There's also several architectures. I'm going to give you a bunch here that I've dealt with and that we've seen in wide practice, but you can see there's quite a bit here. These bounce back and forth a little bit between facts and batch scoring and specific things that you do. I'm going to generalize a bit more, but at any rate, definitely want you to check out. Let's go back to our slide here. Azure Architecture Guide. I'll put myself back over just so you can see straight ahead. Azure Data Architecture Guide. Go in there, take a look at the AI session, and that will give you some more resources. This will be a homework intensive session, some things you can go detangle, but we'll stay at the architecture level while dipping into a couple of solutions, and I'll give you some examples sort of as we go. All right, let's start out with one of our tech spotlights. And the first thing you need to think about is don't write AI, ML, or deep learning. Just don't write it. You're thinking, well, this is odd because we're in a session about how to do that, and you're telling me not to do that. I'm telling you to use pre-built AI wherever you can. What is pre-built AI? Well, basically, it is a system that's waiting for you to make a call, an application programming interface, or API call. And I will show you how to do this, by the way, inside a database. So you can make a call out of your database to a cognitive service. Let me give you an example. For instance, let's say you've got some text and you'd like to get sentiment analysis on that text that's in your database. You've been collecting things from around the web. People are talking about you, and your company says to you, hey, what do people think of us? And you say, well, I could write this whole AI system to figure that out, or you could just use one that people have already written. And Microsoft Azure has a bunch of these. Other companies do as well, but we're focusing here on Azure, obviously. So we're going to take a look at those. So I'm going to show you kind of where those are. Then I'll back out of that and give you, again, some more homework, but then I'll come back to an important point on this particular screen. Let me pop over to your favorite search engine named Bing, and you type in the word Azure Cognitive Services. Azure Cognitive Services right there. Scroll past the ads there, and your first hit should be Cognitive Services APIs for developers. Now let me get my head out of the way here. You can see there's all kinds of documentation and customer stories. These are real live things that people have done. There's frequently asked questions and so on. But there's a quick little video here on what these are. But I'm going to give you the 411 really quick, and then you can mark this as part of your homework as you're doing your architecture research. So I'm just going to scroll down here to the main buckets of the Azure Cognitive Service, and I have another view of this in the slide when we go back to that. But in general, you've got these things here. For instance, in decision area, you can find an anomaly detector. So you're a bank or a hospital, and you need to find anomalies in your data, maybe even manufacturing, and you're looking for anomalies in your manufacturing. You would simply click on here, and then it'll tell you all about how to do that. There's a getting started guide. It tells you how it works and what it does. Again, it's just an API call. You're going to send it data. It will return a prediction. That's the way these always work. Predictions, by the way, are also called scores because they're all guesses, and so a score will include how well it thinks it is trustworthy in that particular thing here. So let me pop back to Slide World. So definitely go out there. Let me get rid of myself for a moment. I'm still here, just getting you some screen real estate. Here's another view of those exact same services that you'll see here. Now, some of these, and by the way, Lewis is just amazing. The language understanding, it is stunning how that works. If you are familiar with 200 years ago when I started in SQL with the English query, the EQ, where you could ask it questions and it would give you answers. This is very similar, but it works. It's amazing, and we're not going to drop it, which I was very sad when we got rid of that. All right, the one thing I wanted to point out here, this same view that you had on your web search, but is these cognitive services containers. This will become very interesting when you start thinking about bringing these containers down, which are not VMs, they're just little carved out memory spaces. We've made some, not all, of these services available to you as containers. Now, when you do that, what you'll get is the ability to run this locally. So it's an Azure service, but you can run it inside your boundary. So you have a Kubernetes or big data cluster that I'll show you later, those sorts of things. That's where you can use these, and you can bring them down. Now you can do your scoring, and you can get your results inside your security boundary. So in a bit, I'll take a look at an example, and I'll show you these actually working. But let's move on to our next tech spotlight here. Let me bring myself back. Here I am. Good stuff. All right, let's move forward in Slide World here. And now let's talk a bit more about Microsoft Azure Synapse. Now, when we talk about Microsoft Azure Synapse, this is the general idea you should think. This is for large-scale data that is either born or sent to the cloud, born in the cloud or sent to the cloud, or you're streaming it in. This is a massively parallel processing engine that uses compute over data, but for relational stores. So what does this provide you? Well, it provides you a couple of areas that are very important when we think about processing for artificial intelligence and machine learning. There's two salient features here that we care about. Above and beyond just being able to query the data with select statements and so on, you have two constructs you want to think about. One is you do have the predict, uppercase, keyword inside Transact SQL. Now what that is, and I'll show you in just a moment more about SQL Server's machine learning services, but the predict statement can take a predefined model, one that you've built, and I'll show you how to do that, and it can then run over that model in Transact SQL like a function. So just like you would do a select with a function, you could select, get your prediction, and then get it as part of the result, which you could then, put in storage, or you could, show, or whatever you want to do. The point is it acts like a function at that point. Conceptually, this is very similar to what we just saw in the cognitive services, if that makes sense. You're going to make a call out of the database, get your score, and come back. In this case, the predict statement is part of the database, and so you don't have to actually go anywhere. You do have to have the model available. This is highly documented. Now, I mentioned there were two parts to this that are very useful. The second part of Microsoft Azure Synapse is the ability to run Spark. And if you're not familiar with Spark, it is another sort of distributed processing system. In general, the way Spark works is this. It basically just transforms storage. I know that sounds a little odd, but what it does is it reads storage up as blocks, and then you can transform those blocks either by doing something where you're adding data or taking it away, or you're just casting it into a new type of data. And it keeps both copies, which is kind of weird. So the storage gets quite large in Spark, but it does very well and has various libraries then it lays in memory over this distributed system. There's a PySpark, which is a Python on Spark. There's a SparklyR, so that you can run R in Spark. There's Spark ML, its own machine learning language. And then it has a language called Scala and a few other things that you can run inside Spark. So it's widely used, and it's available in Azure Synapse. This is a cloud-only offering. So this would be, you would use this in the case of staying completely in the cloud. I won't show you an example of this one, but what I will recommend is you go out, type in Microsoft Azure Synapse in your favorite search engine named Bing, and you'll come back with the documentation. Go through the overview. You'll hit this diagram when you see that, but it is this particular way that it works. And it stores this in data lake storage. So now you start working in sort of data lake things and so on. We're not going to cover data lakes in this session because this is specifically focused on AI, ML, and so on. Data lakes are more of a procedural process to store and process data that can be used for AI, but it is not an AI system. Okay, that's our next technology focus. Moving on, we have the Microsoft Azure Machine Learning. Now, this one's rather interesting because it is not, in fact, a data service, and it's not owned by the data team, but it is so heavily used within data, and there is an example here that you'll need to be familiar with it. It all starts with this concept of a workspace. This is all done on the web. This is a web-only offering as well. And so it's all done on the web. You take some dependencies here. You need an Azure storage account. You need some key vaults. You need application insights and so on. When you set up for the service, it will lay all that down for you. You don't have to think about it. It's going to do all that. It's just those are there. You will then link a couple of services that you have. One is data stores, and that's where our point comes in. When you go do the tutorials from Synapse, you'll notice that it uses Azure Machine Learning, AML we call it. It uses AML to do the processing and uses itself as one of those data stores, right? And then there's also compute targets you can tell the workspace to go use. In addition, you can use various managed resource that it has, such as compute instances that will run your code, Python, R, that sort of thing, the traditional things that you do inside machine learning, and then compute clusters. It has within it environments, experiments, pipelines, data sets, models, and endpoints. I think all those sort of make sense. The environment is the large area you're in to sort of wall that off within, let's say you've got a group inside your organization or whatever. Experiments are individual experiments. Pipelines are obvious. Data sets are obvious. And models are what you create in machine learning. So that's obvious. The endpoints are you can actually do scoring or rescoring or retraining, I should say, inside Azure Machine Learning. It's a very simple platform, all web-based. Looks great, uses notebooks if you want, uses its own drag and drop methodologies. You may see some fairly interesting parallels to things inside SQL Server Integration Services. And there's some real reasons it looks a lot like it. I won't go into those here. Great tool that you can use, and we're going to show this within our architectures, which is why we're sort of giving it a spotlight here. And so definitely something you need to take a look at. Once again, your favorite search engine named Bing, Microsoft Azure Machine Learning. Highly recommend you stand up. We have a free version. Highly recommend you stand one of those up and just do one of the tutorials. I think when you do, you'll say, oh my gosh, I want to do everything this way. And now let's talk about the big one, which is SQL Server Machine Learning Services. Now, what is this? Well, it's the idea of you being able to take a machine learning server, which, let me give you the lineage of that. Back a while ago when I started with the Azure team, we bought Revolution Analytics R, Revo R it's called. And they had an amazing product, and they had an amazing following, and they had some really bright people that I got to work with and for a little while. And that added in then Python. They had a server. They added in Python and so on. Python and R are not inherently server-based. They're locally based. So various companies, Revolution Analytics being one of the main ones, created a server version of this thing so it could scale. So we bought that and so on. And then we renamed that Microsoft Machine Learning Services. So it was a server you could buy. And we added in Python and so on. It also had some really cool functions, RX they started with, that were sort of pre-built things to help R and help Python work even faster and at more scale. That's going to come in to be super important in just a little bit. These tools could build machine learning models. Now what we've done is we took a decision a while back in SQL Server to stand up that server along with SQL Server if you decide. Let me show you sort of what that looks like. If you decide to install it, you check it off here. I want machine learning services, and you tell it which languages, which, by the way, we allow you to extend now. I'm going to show you a process where you can extend this. We have Java, and you can now even install other languages of your own. You could do Go if you wanted to, and it would work in the same way. So let me explain kind of what that sort of looks like. Here's the way things work. You have two ways you can do this. The first is you can tell the server to run stuff, or you can do it like this. The stored procedure call that you see here, you generate a stored procedure, and then you tell it what language you're using, R, Python, Java, or whatever you've installed, and then you can see that there's various boxes here on the right-hand side for the execution. And there's a shared memory channel that works between them. It runs the code for you, but in the stored procedure with all of those security parameters and so on, and then sends back the results. So let's take a look. Let me clear this up a little bit more with an architecture diagram. They're slightly different for Windows and Linux. Let me build out the Windows one, and then I'll show you the Linux one. Here's what it looks like. So I'm looking on the opposite side of what you're doing. So when you see me looking the wrong way, that's why I'm doing that. We've got the SQL Server process that's running in memory and it's protected. We have another process called the Launchpad, and it contains two major pieces, launchpad.exe and launcher.dll. They work on a shared memory pipe, a named pipe. You probably got rid of named pipes on your network, which is a good thing, but this one uses a very secure named pipe. This keeps the two processes completely isolated to where machine learning can't bring down SQL and vice versa. But it allows them to share data and computation, so it's very quick. Now we can have that stored procedure hand off those things incredibly quickly. Now what that does then is using a TCP/IP channel, there's an extension process that does the language executable. Maybe that's R, maybe it's Python, maybe it's some other proprietary system, and it uses a thing called the Bixel server process, and this runs that module And then there's a thing called a SQL satellite DLL that sends the results back to SQL Server across a secure memory location. So that's the way that one works. Now it's slightly different for Linux. Here's what that looks like, because there aren't services in Linux, there's daemons, and the memory process space isn't quite the same. We have a little daemon called Launchpad, which is our daemon, and then you can see the processes spin off here a little differently until it gets to extension and Bixel, and then it looks the same. We don't have named memory pipe or named pipes inside Linux, so we use this process here. So this is how machine learning services works, and I'll explain when and how you might use that as we go through our architecture discussions. All right, now let's talk about those interaction patterns. So we're talking about AI and data interaction patterns, and here are the ones we're going to cover in this session. Now there are more, but these are the buckets that I've chosen. The first one we'll take a look at is database as source. And what I mean by that is the data will reside in a database, and then you'll use AI against that. And there are some best practices and so on. This can be done on premises or in the cloud. It can actually be done on the Azure cloud or any other cloud. And we'll take a look at all of the options that you have here in the next module. Then we have a call to pre-built AI. And this is the one I told you I would show you sort of how that works. The cognitive services here are the ones you can use from us. And then you can build your own and call out to your own API. The API call will be the same, only the setup and teardown and access of the channel will be different if you've built your own pre-built AI. Very common in many organizations. Then we have the database services, which I've just mentioned, which is in database, either training and scoring, or you can score or train or both. And you could train in the cloud and you could score on-prem, or you could score in the cloud and train on-prem. There's reasons you do that, which we'll come to in a minute. You'll have this inside SQL Server virtual machines. You'll have it inside BDC, big data clusters. You'll have it inside managed instance. And you'll have it in the new SQL Edge as well, at least the scoring that you'll see there. And here also, I didn't put in Synapse because you don't normally score from Synapse, but you could, and we'll talk about those patterns as well. So Azure Synapse would be another option you have here. The last pattern I won't show you an example for because it could be just about anything, but we'll talk through a hybrid scenario so that you can see sort of how that works. So I think what we do now is let's just dive into these. We'll just take them one at a time, look at these architectures, have the discussion, and then maybe show some examples along the way. Let's take a look at our first design pattern, which is the database as source. This is actually the simplest, but I did want to show you an example just for completeness sake. So we'll take any database, and this literally can be any database at all, and even not a database, right? So a relational database management system, this could be Azure SQL, like a cloud RDBMS. It could be SQL Server on-prem, could be SQL Server in a VM, could be Postgres, could be Oracle if you have to do that. We support that just fine. And then cloud storage as well, even just regular cloud storage. As long as you can get it into something your code can swallow, you're in good shape. Now here's the first kind of pattern. So you have the database itself somewhere, or maybe you have all of these, which is very common, and we'll take a look at that more in the hybrid area. And then you've got your, let's say, this is one option, your on-prem systems, big data clusters, SQL Server using machine learning services, or even just code, even just regular code. What you can do is you can call out to those databases and then get a response back. I've got the lines in blue. Hopefully that renders okay. But the lines in blue there when they go to the cloud, black when they're on-prem. Notice that the RDBMS may be in the cloud. So you can make your connection, you bring the data in, and then I've got these icons down here you can see. The little brain icon means that you've got the model sort of created. The little experimentation, little flask there means to run your experimentation for your machine learning algorithms. And then the learning there is the training part of what you're going to do. And the percentage there means to score. So you could hit any of those endpoints. Now you can also do that in the cloud, and you could hit from cloud to on-prem. There's patterns for that. There's patterns from going on-prem, or rather in the cloud to in the cloud to cloud storage, or in the cloud even to another cloud. Once again, you see you have all the options, sort of the training, the experimentation, the model creation, and the scoring in both places. And what that basically means, let's see if I've got my, oh good, I'm out of the way of my little icons here. That's good. I wasn't sure about that. You can make your calling app, the application on the back end side. You have two patterns here. One is you can have the application located on the application so that it calls into these things. The other way you could do it is you could have a web service, let's say, or something on-prem or in the cloud, or both, that will just, they'll do the work, and then this just a presentation layer out to your application. So I think let's see an example of this. This is the simplest design pattern, but it's one you should sketch out when you're creating your solution. And once again, I'm going to come to you with a hybrid solution, so we're going to group all of these at the very end. It'll be a kind of a confusing solution there. All right, here we go. Not confusing, but a lot. There's a lot going on. Let's use a database as source. What we're going to do, I didn't finish my text, to send to an AI processing system. That's pretty obvious. There's the documentation if you'd like to do this yourself. I'm actually running Python. I'm in the Azure Data Studio tool. That's where we'll be for today. And I'm using notebooks, Jupyter notebooks. If that's new to you, write that down. Basically, a notebook, this is wrong, but it's close enough, is a web page with two kinds of attributes. One's called a text cell and the other's called a code cell. And that code cell, which you can obviously see here, this is text here and this is code here, right? Depends on the kernel, Kernel, that you run. And you can see that we include several with Azure Data Studio, from SQL to Python and so on. And I'm actually going to run this simulating an application, meaning the local host is going to do the work. This is called your context. All right, just you have that. Python is the code we're going to run today. This could work in R or any other language for that matter. Again, this is not strictly a database issue here. I'm just showing you an example. And it needs something called packages. And these are basically just included code that somebody else wrote that you want to leverage. And it uses a program to do that called pip, Python Interactive something, Package Manager, something like that. Anyway, whatever that acronym is. I always use Python mpip, by the way. You'll see that. I tend to do that, or there's other ways to do it. I've got both examples here, pip. If you do pip, it's going to install in the Python that is your default. But if you are using environments in Python, which many people do, meaning multiple, think of instances in SQL Server, it's best to run your Python and then run the program called pip. And now you'll make sure you're in the right place for there. So I upgrade my own pip and then I install PyODBC. I'll bet you can guess what that does. And then a data language or data package called pandas, Python data services. Okay, so the first thing I'm going to do is I'm just going to create my, get my PyODBC. I'm going to use matplotlib to do some graphics. I'm going to use numerics. I'm going to use panda. I'm going to use SciPy and scikit-learn as the packages that I need. Okay, with all of that done, all I'm going to do here is set up my driver, and no, I'm not going to give you my server name and password, but this could be any connection string that ODBC can handle. That's the key. That's the whole point of this particular scenario. And then I just build a query. We're not going to worry about that right now. It's a query in SQL that's going to return some data. Now that's come back to me over the wire. It's come back to me now. I'm going to import those columns. I'm going to do some work here. This is just clustering, and I'm just getting a k-means clustering just to cluster some things together. This is to group, let's say, customers together. And I see that cluster 0 has this, and cluster 1 has this, 2, 3, and so on. And what this would do is say, hey, if you make from this to this, you're in this bucket. If you make from this to this, you're in this bucket. If you make from this to this, you're in this bucket, and so on. So this groups my customers together, let's say, so I could see things. This could also be medical things and so on. So you get the general idea. Let me go back to slide world here. I'm moving my mouse around frantically. And this is our design pattern. Simplest one, but it's one you should be familiar with and you should be able to diagram. You're welcome to any of these icons or anything. But again, as I showed you earlier, that data access guide has tons of icons and Visio primitives for you to use. So this is our first design pattern. Okay, so our next pattern is the one I mentioned at the very beginning there, which is don't write your own, just call out to pre-built AI. This is my favorite. I love leveraging other people's work, meaning that I don't work a lot, I get other people to do it. And that's a smart thing to do because here's the other advantage with pre-built AI. As it gets improved, your code just improves with it. So they make a change to make it even better at image recognition. Well, now your image recognition just got a lot better. And that's amazing and something you should definitely think about. All right, here we go. Let's take a look at how this guy works. First of all, we're going to start at the other end. So we start at the back end first time. We're going to start at the calling application, and here's what it does. It's going to call to the database. This should look very familiar because this should be just about every application you have if you're using SQL Server. Now what I can do is inside SQL Server, I'm able through various methods to make a call out to cognitive services for the scoring. Now, it should be noted, and I didn't mention this when we were talking about cognitive services, but some of those can take some sort of extra parameters, if you wish, to do a little light training to modify what you have. Let me give you an example. In the image recognition, it can recognize that's Bill Gates, you're at Mount Rushmore, and so on. There are 13 people, they are this year, many years old, it can guess all those things. But maybe you want to know a specific thing, like not just coffee cups, but this coffee cup, the one that has the caffeine molecule on it. So you want to train lots of images of this cup, and you want to be able to recognize this cup in a picture, but using pre-built AI. Normally, if it's not in the model, it can't guess this particular one, but some of these actually can take some parameters, say, hey, send me some stuff and I'll train on it. And then it gets better as it goes on. All right, that was a little aside there. This is a very simple one too. That's why I don't even know if you can see it, but right here, there's a real light color of the training here. And the reason why is because there's some light training that some of the services can do. Just go look up that list we showed at the very beginning, and it will show you those. So this is a pretty simple pattern to use. And there's various ways you can do it, as I mentioned. You need to be able to make an API call from SQL Server out to the web. That's the key here. Or if you're using your own APIs, you need to be able to make an API call. Now, there's a lot of ways to do that. You could write a CLR and so on. I'm going to stick, let's jump over to an example. I'll show you this one. I'm going to show you an example of text analysis of database records using cognitive services, and I'm going to use Python. All right, so to do that, I need to have machine learning services installed on my SQL Server so I can run Python. I'm not going to do the training this time in my database. I'll do that later. This time I'm going to use somebody else's training, but I need to be able to make an API call. To do that, I need to install some libraries. And the interesting thing is I'm using big data clusters. I've just got a big data clusters machine here with my databases and so on it. So to do that, because it's running inside Kubernetes, this particular one could be running in OpenShift as well, I need to be able to get into that pod and that specific container, and I need to go into Python, and I need to install the Azure AI Text Analytics package. Okay, all that does for me is allow me to send very quickly the keys and my endpoint to be able to do that. Hopefully, let me make sure. Good. Let me make sure I didn't give you, okay, I hid my endpoints. I was worried. I run all these. This is all real code, but I can't leave my keys and so on in there. So I would have had to scrap this video and start over if I hadn't taken it out. All right. So you can also use ML utils. That's another package that we make in SQL Server to do installs of packages in SQL Server. I did it this way. This shows another way. That's the way to do it. All right. All I'm going to do is go get my review content from product reviews where review equals this number and so on. So people have written some stuff about my company or my product. Here it is. This one says works fine, easy to install. Some reviews talk about not fitting wall plates, designed for the best wall, and so on. This says works fine, but it has in here about not fitting wall plates. So is it positive? Is it negative? If you were just reading that and you're a computer, you wouldn't know what to do with that. Let's see how well it does. So all I'm going to do is I'm going to just execute some stored procedures here, and I'm just going to use Python. I'm going to do that exact same product review, no big deal. I'm going to set my key, my endpoint. That's the magic here, the key and the endpoint. That's why I needed that package to be able to make an API call. There are other ways to make API calls out of a database. This is the one I chose. And so all I'm going to do is import my text analytics client, get my credentials, and get some JSON so that it can handle JSON and so on. I'm just going to authenticate. That's all that's happening here. No magic. And I'm just going to say, hey, did you connect? And it's going to connect. And then I'm going to say the document that I'm going to send is equal to this, which is just this up here. That's my input data. Input data, see that? See that right there? That's the default, by the way, inside there. And you can go and read documentation for more of this. And then basically, I'm just going to define my sentiment analysis, and I'm just going to get a positive, a negative, and a neutral, and just get a score range when it comes back. I want words. I don't want, a percentage. I want actual words. And then basically, hey, go do that. And just give me all those scores. Send that sentence up and tell me. And when it comes back, it says analysis complete. And here we go. It says sentence 1 sentiment is positive. Sentence 2 sentence is not fitting wall plates is there, right? Sentence 2 is positive. Sentence 3 is negative. And so on. Now, why did I show this particular one? Because I actually wanted to show you that sometimes things are nuanced. For instance, you might get a review that says, I liked it, but it started a fire on my stove, so I wouldn't buy it again. Well, they did like it. They just didn't like that it started a fire on their stove. So that might flag to the person who's doing the product reviews, hey, we may want to take a look at this. People generally like us, but we catch things on fire. You get the general idea here. And then basically, it just basically comes back and gives you all of those things. And it was very, very quick. So that's the call to pre-built AI. Once again, let's go back to Slide World here and just see that pattern. One of the simplest patterns there is, and something you should look at all the cognitive services and look at your data and say, is this something we could be using? And I'll bet you can. Our next design pattern is the one we mentioned with SQL Server machine learning services. So we have a couple of these that we can actually show, but let's take a look at the in-database train and score process. And once again, we're going to start with the idea of the application, and we're just going to go to the meta. What do we want to do? We want to experiment. And just to be clear about that, whenever we follow the team data science process, and if that's new to you, type in team data science process Microsoft, and we've written an entire process for doing machine learning in your company, and it's an industry standard. I got to be part of developing that, so a lot of the code that you'll see there and the documentation you'll see there's stuff I've written, so you definitely want to take a look at the team data science process. Lots of good information out there. Anyway, you've got an application and you want to do some training. You want to do some experimentation, and you want to store your models and so on, and then you want to score. You have two big places to do this. I'll show you one example, and then we'll modify that slightly. So the first is you can use on-prem SQL Server, and SQL Server machine learning services, especially SQL Server 2019, has some really powerful machine learning services built right in. And I'll show you an example of that. We've been doing Python. We'll switch to R for this particular use case. SQL Server on Linux and even in containers still can install machine learning services. Separate step. We don't include it by default. There's some steps you take, well documented. except for big data clusters, which has it installed by default. And that's actually what I'll be hitting for mine. So those are the options you have on premises for machine learning. You also have cloud options. And by the way, once again, you can do both of these. Azure SQL Server Virtual Machine is just SQL Server, and you can install machine learning services on that. SQL DB has machine learning services, a lighter version that you can use inside. Synapse has the predict statement, which we'll see in a bit. SQL Server Managed Instance, where you have a SQL Server, but we take care of it for you. Is an amazing product. If you've not looked at that, definitely take a peek. That can do a level of machine learning services. And SQL Server Edge can be used for the scoring. All right, so this is the general pattern, not that complicated. You're going to have a stored procedure, just like we did in the previous example, but in this case, you're not going to call out to AI. You're going to build your own. Let's go do one. I'll just use a very simple example. Where are we at here? Here we go. All right, here we are. I'm going to use R and SQL Server Stored Procedure. Once again, I'm hitting my big data cluster that you can see up here that I've connected to. Okay, so I'm going to use a database I've got called Analysis, and I'm actually going to use a built-in data set. This is just an example, so the data set's not important. There is a sample data set inside R called CARS, and it's to predict who will have the best gas mileage, fuel mileage if you're in the UK or everywhere else. They find it humorous when we say gas. I lived in the UK for many years, and there were some various words that got me in a little bit of trouble. Gas is one of those. At any rate, we say miles per gallon. I'm not sure what they use, kilowatts or whatever it is. Anyway, the point is you want to say, how well will this car do? Now, this is how old this data set is. This is from the US, and it actually had whether it was a manual transmission or not. No cars in the US have that anymore except sports cars. I grew up on a manual transmission, so I still at least have that in common with my UK friends. So there's some various things. Miles per gallon, again, we use that in the States. Cylinders, displacement, horsepower, once again, we use that in the States, and so on. Dry weights and the weight and so on. How many gears and how it's carbureted. It even goes back to carburetors. If you don't know what those are, don't worry about it. Here, anyway, what I'm going to do is I'm actually going to run an R script that takes data out of R, this thing, and puts it back in a variable that I'm going to output as a thing called mtcars. And I'm just doing an insert into using a function. So all I've done here is grabbed data out of R and put it in the database just so you have an example of this. I want this to be a universally available example, so this will work pretty much anywhere R will run, which is why I chose R, by the way, because you have some of that inside some of the offerings and not Python. So I kept it in R. You see what I'm doing there. All right, here we go. Now we're just going to get our predictions stored procedure. It's very simple. This is an incredibly simple R function. If you don't know what it is, it doesn't matter. The point is, this is the language I'm going to use. This is what I'm going to send in to the script, to that language. Then this is what I'm going to send as data into that script right here. You can probably start figuring it out now as I go. And then what I'm going to output is the trained model, the actual binary model that I train inside R, and I'm going to store that model in a field. Isn't that amazing? Now what I do here is I'm just going to go make the database or a table to hold that data when it comes back. And here's what's kind of interesting. When I insert into that model here, insert into GLM models that you can see right here, exec. When I insert the model that I've built, I could also include like a version number or a date and time stamp or an author or whatever. I can begin to version my models. This is very important inside machine learning. This is one of the reasons you would use SQL Server as a machine learning scoring, training, and so on source. Now what we can do, in fact, I've got I actually made it my default model there. I actually added a column here. You can see that I did that. All right. Now what I'm going to do is I'm going to throw some new cars into a table. Now this is for something called batch scoring. Now what I'm able to do at this point, I'm actually able to send in a select statement of some variables, send it to the prediction model that I've stored, and it will score it for me. That's called inline scoring, or just scoring. However, I may have an entire table of data, and at the end of the day, at the end of the month, fourth quarter, whatever, or real time, I want to go send all of that data in and get a score back for every single one of them, potentially even putting that back in the database. When I say score, by the way, remember that's the prediction, and it's how well the prediction does. So I've just inserted some new cars, and it turns out the ones we care about are the horsepower and the weight. That's what we seem to care about for doing these predictions. So you can see my very well done script there. I've missed a semicolon. I'm sorry. I should have put those in. I'm usually good about that. So now all I'm going to do is just get my model as a var binary. I'm going to go get the model I want. Keep in mind, in many shops, you'll want to predict using various models to see how well they perform. Perform inside machine learning doesn't mean how fast it goes. It means how well it does. So when you hear about the performance of a model, we're not talking about the speed, which can be very confusing. All right, here we're going to do, all I'm going to do is send in the R. I'm going to go get the predicted amount from what I just stored up in my new cars, the things that I'm evaluating, and it will bring me a result set. This is a batch score. So for every one of these values, it returned the values, because that's what I asked for, and it returned the predicted value that I was looking for. So you can see the predictions are here, and these are in percentages, of course, so you can see kind of how that's working out. So that's the way you can do in database. I've shown you in database experimentation with the models. And you get back how well the model's doing and so on, so you can pick out the one you like. You normally do several, and different hyperparameters and different things that you send into the model. You saw how to actually train the model on the data we had, which is just from MT cars. And then you saw how to score. I've told you how you can do a single score, and by the way, that single score, all you would do to do that is, rather than doing this, right here, where you're selecting from a table of data, you would have just sent it with a select statement to the data that you want right this second. So you could do that line by line inside a stored proc or whatever, or you could do it as I've done here, which is called batch mode scoring. Okay, there's one more example I wanted to show you very quickly. This is not for training and not for experimentation. We're going to assume in this example that you've done that, and you're using one of the RX functions. Now, there's documentation for all this statement and so on. Basically, Microsoft includes some pre-built models using the RX functions that I mentioned about long ago when we bought the Revolution Analytics folks. They made some great tools, and so we just embedded those within the database, and you don't need to do any training. This is a little like the call to pre-built AI, but it is in database work, so I've put it in this section. And all I'm going to do here is go after the iris. I'm just going to do this very quickly. This can be used inside Azure Synapse as well as SQL Server and the other locations that I mentioned. So I'm just going after the iris prediction. This is just a very, very, very old statistical problem used quite often in R classes and so on that predicts the particular class or genus of a flower. That's all it does. Okay, so, and it happens to do with sepal and petal widths and species and so on. We're not going to get into why. It's a very simple data set to understand. All right, so I'm just going to create a table. This is what we did earlier, and just sort of fill it out just like we did before. I'm just going to take the iris data table and then fill it with the iris sample data from R. So just forget that. Here's our model again. We've done the same thing here. In this case, I'm going to go create my model here, and this is just using the RX functions and so on. We're assuming that part has been done and stored, and it's based on one of the RXs. Now you simply ship that model to the new section here, and then what can happen is you can use the predict statement. So here, this code here, you do not need to run the training stuff on the other system to be able to use this if it meets certain criteria. But assuming that it does, and it's a pretty healthy way to do it, you simply tell it the model you're going to send, and the data you want. So this is all you have to do to make all that work. So it's assuming the training's been done somewhere else and the experimentation and the model's been persisted, and you have that stored somewhere and it was built on some of the RX functions. If all those things are true, you simply go grab the model and do a simple predict statement. Very powerful. Just thought I would show that to you really quick. All right, we're in home stretch here. We're looking at our final design pattern that we'll consider at this time. This one is the hybrid, and so I've kind of built out everything here from the calling app to all of the options I've shown you. Now, I haven't shown you the cloud storage one. I didn't mention that. Cloud storage is simply cloud storage, so you would need to read that in. Lots of ways to do that. You can use Polybase in SQL Server. You could use Python and read it in and stick it in a data frame. You could use R and read it in and stick it in a data frame and so on. But I've sort of built out everything here. This is the way you need to be thinking, even if you've chosen one of the other models. Always think about how could this be a hybrid solution. What does hybrid solution mean? It means you're not going to constrict what you're going to do based on what you know. It's basically going to let the requirements of the solution dictate what you're going to try to accomplish. So let's take a look at how we've got here. So we've got all our pieces. Let's walk through. The first thing is you could have a calling application on your phone or on a computer or whatever it happens to be, on the shop room floor, whatever it happens to be, that could call to your own system to either use the database as a source, and you can see all of the icons, the training, the models, the experimentation, and the scoring could all be done sort of here. Notice also then that application, and you can barely see the light blues there, could be calling out to the other systems. So say, for instance, you've got a pattern here where I do the machine learning inside SQL Server, but I want to leverage one of the AI. Maybe I want to do some really deep stuff, and I just want to leverage some AI that's out in the cognitive services, so I do that. Or perhaps some of my data is in the Azure ML, or rather the Azure services, to get the data to do my training. So I'm going to make a call out there using Polybase or something like that. So draw out these lines this way. So this is a single call into this, but that's not the only way to do it. Once you're done, you could shove that out into SQL Edge, which is a small device, very small device that can run SQL Server, and it can run the prediction capabilities of machine learning services. So now all the way out in the vehicle or in the Space Center or in the pricing wand or whatever it happens to be, you can do your predictions there. You can change anything you'd like to change within that. So this is one pattern. Another pattern then is you could go the other way. You could make out a call to almost any of the cloud services. Almost all of them have a gateway product to come back in. So you want to be thinking about these patterns as you go. This gets very complicated, so I wanted to pop over to a couple of resources here that we have available to kind of help you with that. Remember that data architecture guide I mentioned, and it brought you down here into the data architecture guide. I want you to come up here and take a look at the Microsoft Azure well-architected frameworks. I want you to get to that location. You can also just type in Microsoft Azure well-architected framework, and your favorite search engine named Bing will bring you here. But these are some tenets you can use that will guide you through making your decision. And these are usually, we call them pillars, but these are usually the reasons you're doing this. We don't usually do something in an organization or company without a real reason. So, and they usually involve one or more of these. We either need to change cost because things are costing too much. This is number one, as you can see, and it's probably the one you should start with, where you can add value to our organization. So I'm just going to open that in a new tab here. And if you come in here, it basically gives you everything you need to know. And as you begin to coming into a cost optimization, you can start finding things like a cost model checklist, how you capture your requirements and so on, the cost model that you're going to use for your artificial intelligence program, and so on. Everything is here. So if you're not making use of this, you're missing out. There's just so much information in here. about what you need to think about. Again, when I was an IT director, I lived on the Microsoft patterns and practices. We do so much work for you. Learn from me, Anakin. Use my knowledge. Okay, I'm sorry, that was uncalled for. All right, so definitely check out the well-architected framework. There's operational excellence if you've got some things that you need resiliency for, if you need to work faster, if you need to make sure it's reliable, and you should always, I'm sad that this is at the bottom, but it is for a lot of folks. If you've got a high security framework, take a look at this, and it shows you the different things to look at. Now, I highly advise you just wander through these regardless, even if you're not an architect. If you're a developer or a data professional and you're not called an architect, I still think you should be familiar with these. Now, if machine learning is new to you, and it shouldn't be if you're watching this session, but if it is, that's okay. We're going to help you out. Type in AI School. You can even spell it correctly if you want. There we go. In your favorite search engine named Bing. It even figured that out, even though I spelled it wrong. And you'll come to this AI School at Microsoft. This is a free set of resources where you can learn all kinds of things to sort of start building a path to help you with training. And it's everything you could possibly need here. And not only that, most of these lessons are completely free, and you're able to work through them at your own pace and get yourself set up that way. All right, back to our hybrid that we were talking about. Let's go ahead and close out our session here today. Oh, by the way, I missed deploying that to the edge, but I think that's pretty obvious. There we go. The folks here at PASS Conference really want you to fill out your evaluations, and I do too. I want to know and get better if I can. Hopefully this has been of value to you. I always enjoy architecture, even when I'm deep. I like to go wide on these things as well from time to time, just to make sure I'm not missing anything and that I'm doing sort of the right paths on things. But definitely go and fill out that evaluations. They give you prizes and stuff for doing that. I want to make sure that I thank you very much. Oh, let me get out of the way of the logo here. Hold on, I'm in the wrong, oh, well, too late. Anyway, I'll get bigger. How's that? There we go. There I am. Listen, I want to thank you for the time that you've spent here today. There's lots more to learn, and there's other sessions that you can take advantage of here at PASS. Definitely go check out what they've done for you and the different parts. We're a community. Help each other out. Hit me up on Twitter, Facebook, or LinkedIn. And once again, thanks for your time.